Welcome back. In our previous video, we explored what Kafka is, why it's used, and who commonly uses it. Now, it's time to dive into Kafka's architecture and take a closer look. Let's jump right in. The core components of Kafka architecture include controllers, brokers which contain topics and partitions, producers and consumers. Let's gain a deeper understanding of each component. When it comes to controllers, they play a crucial role in managing metadata and coordinating the Kafka cluster. Let's illustrate this with an example for better understanding. We're going to understand Kafka Kraft controllers using something familiar, a school. Imagine Kafka as our school, and the principal as the Kafka controller. Let's see how things worked before and after Kraft. Before Kraft, Kafkawithoutzookeeper, principal reports to a school board. Think of a school where the principal, Kafka controller, isn't fully in charge. Every time they need to make an important decision, like hiring a new teacher or shifting a student to another class, they must first ask the school board, zookeeper, for approval. What's the problem? Slow decision-making. The principal has to wait for the school board to respond. Too much dependency. If the board is unavailable, the school can't function properly. Risk of failure. If the board stops working, the principal is stuck and school operations freeze. After Kraft, Kafka with no zookeeper, principal has full control now. Imagine the school removes the school board and gives full authority to the principal and their assistant principals, Kraft controllers. One principal, leader controller, is chosen. Assistant principals, follower controllers, help manage decisions. All decisions are written down in school records, metadata log, so everyone stays updated. How is this better? Faster decisions. The principal doesn't have to wait for approvals. More independence. The school can run smoothly on its own. Stronger backup system. If the principal leaves, an assistant can take over immediately. Let's discuss Kafka brokers. These as servers that store data and serve clients within a Kafka cluster. Each broker contains topics and their partitions. A topic is similar to a folder in a file system, where events act as files stored within it. A partition is an ordered, immutable sequence of records that allows Kafka to scale efficiently. However, Kafka does not guarantee message order across different partitions. Let's look into it with an example. Imagine Kafka as an online exam system where multiple students are taking tests at the same time. A Kafka broker is like an exam center that conducts tests and manages student submissions. Example: suppose there are 3 exam centers across different cities, Broker 1, Broker 2, and Broker 3. Each exam center receives, stores, and processes test submissions from students. A Kafka topic is like an exam subject, such as mathematics, science, English. Each topic contains multiple student submissions. All submissions for a particular subject go to the respective topic. Since thousands of students take the same exam, distributing the load efficiently is essential. Kafka partitions a topic across multiple brokers, just like exam papers are distributed among different exam centers for evaluation. Example: the mathematics topic is split into 3 partitions. Partition 0, stored in Broker 1, evaluating first batch of math papers. Partition 1, stored in Broker 2, evaluating second batch of math papers. Partition 2, stored in Broker 3, evaluating third batch of math papers. Each broker, exam center, processes its assigned batch independently and in parallel, making the system faster and more scalable. Now let's dive into producers and consumers in Kafka. In Kafka, a producer is responsible for sending data to a Kafka topic, while a consumer retrieves and processes data from a Kafka topic. These two components work together to enable seamless real-time data streaming and processing. Let me illustrate this with an example. Imagine an online shopping platform where the customer, producer, places an order, and the delivery agent, consumer, picks up and delivers the order. Great. Now that we have a clear understanding of the core components of Kafka architecture, we are ready to try it out ourselves and see how it works in real time. In the next video, I will walk you through a hands-on demo session to bring these concepts to life. Stay tuned.